Hey robotics folks, it's Miss Haynes. It is this is the second part of what I'm putting up regarding pseudocode for today. And and so if you've already done the one where I've asked you to like break down brushing your teeth into 5 steps and tell me why we need to have these sort of concepts of complex, simple, and basic behaviors when we're talking about programming something. So I put this little image up. This is something on PLTW's site. And it again breaks down sort of how the breaking down process turns into usable coding information. So if you start with a large-scale behavior that solves a problem, let's say your behavior is follow the path to reach a goal, you can't just tell the robot, follow the path to reach the goal. It doesn't know what that means. So you're going to have to break it down into smaller pieces. So the first step usually is think about the simple behaviors that have to happen. Like if you know what the path looks like, you know you're going to have to go forward for a little while, maybe 3 seconds works, turn left 90 degrees, go forward that direction 5 seconds, turn right 90 degrees, go forward. You know, you've got this idea about, okay, I'm going to go straight, I'm going to turn left, I'm going to go left, you know, that direction, go. You know, you got this idea about what the path is it has to take and how it gets to where it needs to go. So those are the simple behaviors in this case. You may have a couple stages of simple behaviors while you break things down more and more, but then at the very end goal is to see what line items of code would cause the simple behaviors that together cause the complex behavior. So if your simple behavior is go forward for 3 seconds, you've got a robot where you've got to turn on the left motor and turn on the right motor. It doesn't matter left motor's first, right motor's first. It doesn't matter that one is before the other one. A computer will process it so quickly, it's basically turning both on at the same time. If you say turn on left motor, turn on right motor, it'll basically be instantaneous. Both of them turn on. When you have something that says wait 3 seconds, now that waiting is where it just lets them run without changing anything. It lets the light be on for 3 seconds if you turn a light on. It lets things stay the same while it waits that time. And then it does the next stuff. In this case, turn off left motor, turn off right motor, which again sort of happens instantaneously because computer processing speed is so quick, both of them turn off. So what you've done is you've turned your motors on, they go for 3 seconds, you turn them off. And that's 5 lines of code to make it go forward for 3 seconds. And that's it. There's some more examples in here. This last example, they did not finish. They did not turn it off after 5 seconds. But basically, you keep going until you get small enough behaviors for your coding. And we're gonna be working a little bit with actual line by line coding instead of drag and drop coding. You may have experienced drag and drop before. Some of you may have experienced line by line coding before as well, and that is okay. If you haven't, and if you have, it's okay. I mean, if you might be a little bit ahead of the curve if you've experienced it. So what I'm going to do is I'm going to put up a quiz that's just going to be, it's probably going to have just essay questions. I have to finish making it. I'm going to give you like a complex behavior, and you can then break it down into simple behaviors. Maybe I'll just start with simple behaviors because if I say go forward for 3 seconds, you can get the idea. I've got to turn on both the motors. It's got to go wait for 3 seconds. It's got to turn both of them off. So if I just say follow the path to reach the goal, you don't know what the path looks like and you have no experience with how long it takes to drive along a certain chunk of the path. So let's go with that. For the purposes of our, this activity today, assume that if you turn the motors in opposite directions and wait for 0.8 seconds, that'll be a 90-degree turn. If you're reversing, let's really quickly talk about turning. If I'm moving my left motor backwards and my right motor forwards, I don't know if I'm reversed for you guys. If I'm moving left backwards and right forwards, I'm turning left. If I'm moving right backwards and left forwards, I'm turning to the right. All right. So if I have something to turn right 90 degrees, well, it's going to be, the left motor is going to be turned on forward and the right motor is going to be turned on backwards. Then you wait and turn off. So there you go. There you have it. Yeah. Go check out the little quiz. It shouldn't take very long. Make sure that you've done the bell work for the day. Make sure you've completed. If you hadn't done it in person, make sure you did that other activity as well. And yeah, hopefully y'all stay safe and warm and healthy and happy. And I will see some of you around 9 o'clock on Monday if you have any questions.